Imagine a world where lakes and rivers flow across the landscape, where rain falls from cloudy skies, and where a thick atmosphere shrouds the surface in orange haze. Now imagine this world is over 800 million miles from the sun, where temperatures plunge to minus 290 degrees Fahrenheit, and where those rivers aren't filled with water, but with liquid methane and ethane. Welcome to Titan, Saturn's largest moon and one of the most extraordinary places in our solar system. If you're fascinated by the mysteries of our cosmic neighborhood and want to explore more alien worlds with us, make sure to hit that subscribe button and ring the notification bell. You won't want to miss our journey through the wonders of the universe. A moon like no other Titan is the second largest moon in the solar system, larger even than the planet Mercury, though less massive because it's composed mostly of ice rather than rock and metal. Discovered in 1655 by Dutch astronomer Christian Huygens, Titan was the first known moon of Saturn and only the sixth satellite discovered in the entire solar system. But what makes Titan truly special isn't just its size. It's the only moon in our solar system with a substantial atmosphere, one that's actually denser than Earth's. Titan's atmosphere is 4 times denser than our own, creating a thick orange haze that obscured its surface from astronomers for centuries. Until NASA's Cassini spacecraft began its mission in 2004, we had no clear understanding of what lay beneath those clouds. The atmosphere is composed primarily of nitrogen, about 95%, much like Earth's 78% nitrogen content. The remaining 5% is mostly methane, with traces of other organic compounds. This nitrogen-rich atmosphere is one of several striking parallels between Titan and Earth, though as we'll see, the similarities end there. An alien landscape. When Cassini finally pierced Titan's haze with radar imaging and infrared cameras, it revealed a landscape that was simultaneously familiar and utterly alien. The moon's surface features rivers, lakes, and seas, the only confirmed stable bodies of surface liquid in the solar system beyond Earth. But these aren't water. At Titan's frigid temperatures, water is as hard as rock. Instead, these lakes and seas are filled with liquid methane and ethane, hydrocarbons that exist as gases here on Earth. The surface displays remarkable geological diversity. There are vast dune fields near the equator, stretching for hundreds of kilometers. Organic sand composed of complex hydrocarbons that rain down from the atmosphere. There are mysterious magic islands, bright spots in radar imagery that appear and disappear in Titan's liquid bodies, which recent research suggests are likely floating chunks of porous, icy organic solids rather than gas bubbles as previously thought. Mountains rise from the icy surface, and there's evidence of possible cryovolcanoes, ice volcanoes that may erupt liquid water mixed with ammonia instead of molten rock. The surface is remarkably smooth with few impact craters, suggesting it's geologically young and still actively shaped by ongoing processes. Beneath this exotic surface lies another surprise. Titan contains a subsurface ocean of liquid water mixed with ammonia, similar to several other moons in the outer solar system. This hidden ocean, trapped between layers of ice, raises fascinating questions about the moon's internal structure and potential for harboring life. Breaking the rules of chemistry. Recent discoveries have made Titan even more intriguing. In October 2025, scientists announced that Titan appears to violate one of chemistry's most fundamental rules. Researchers found that polar and nonpolar molecules, substances that normally refuse to mix like oil and water, can form stable crystals together under Titan's extreme cold. Laboratory experiments simulating Titan's atmosphere at temperatures around minus 180 degrees Celsius revealed that hydrogen cyanide, a highly polar molecule, can combine with nonpolar hydrocarbons like methane and ethane to form co-crystals. This unexpected chemistry could fundamentally change our understanding of what's happening on Titan's surface and in its atmosphere. These co-crystals might explain the fate of hydrogen cyanide that falls from the atmosphere and could influence the formation of Titan's lakes, seas, and dune fields. Adding another layer of mystery, scientists discovered in 2024 that methane gas may be trapped within Titan's icy surface, forming a distinct crust up to 6 miles thick. This methane-rich layer acts as an insulating blanket, warming the ice shell beneath it and potentially explaining how Titan maintains its methane-rich atmosphere over geological timescales. Titan's atmosphere has revealed another puzzle. Using 13 years of thermal infrared observations from Cassini, researchers discovered that Titan's thick atmosphere doesn't spin in alignment with its surface. Instead, it wobbles like a gyroscope, shifting with the seasons. What's particularly puzzling is that this tilt direction remains fixed in space rather than being influenced by the Sun or Saturn, which would have provided clues to its cause. Each season on Titan lasts nearly 30 Earth years, and the atmosphere's behavior shifts accordingly. The winds in Titan's upper atmosphere blow about 20 times faster than the surface rotates below, creating a dramatically different dynamic than anything we see on Earth. A laboratory for life's origins. Perhaps Titan's greatest significance lies in what it can teach us about the origins of life. The Moon is often described as an analog to early Earth, a chemical laboratory conducting experiments in prebiotic chemistry. In July 2025, NASA researchers published a study identifying that cell-like compartments called vesicles, needed to form the precursors of living cells, could potentially form in Titan's hydrocarbon lakes. The Moon possesses many of the building blocks necessary for life as we know it: complex organic molecules, energy from sunlight and cosmic rays, and liquid. Even if that liquid is methane rather than water. Scientists believe that impact craters and possible cryovolcanic activity could occasionally provide liquid water, creating temporary environments where water and organic compounds might interact to produce even more complex chemistry. Titan's atmosphere continuously produces organic molecules through photochemistry, sunlight breaking apart methane and nitrogen molecules that then recombine in increasingly complex ways. These organic compounds fall to the surface like a gentle snow, accumulating over millions of years. Some scientists speculate that Titan may have been conducting chemistry experiments relevant to life's origins for billions of years, with the results simply waiting to be discovered and analyzed. The Dragonfly mission. Understanding Titan's mysteries will take a giant leap forward with NASA's Dragonfly mission confirmed in April 2024. With a total life cycle cost of $3.35 billion, Dragonfly is scheduled to launch in July 2028 and arrive at Titan in 2034. Dragonfly will be unlike any spacecraft we've sent to another world. It's a dual quadcopter rotorcraft, essentially a large drone with 8 rotors, that will fly like a helicopter across Titan's surface. Titan's dense atmosphere, combined with its low gravity, just 1/7 of Earth's, and frigid temperatures make it an ideal environment for flight, allowing Dragonfly to stay aloft easily and fly faster and farther with minimal energy. Over its planned 3.3-year mission, Dragonfly will travel up to 70 miles across Titan, stopping at dozens of geologically diverse locations to sample surface materials and study the moon's chemistry. The mission is expected to fly more than 160 kilometers, almost double the distance traveled by all Mars rovers combined. The rotorcraft will land at various sites, analyze surface composition, and then take off again to explore completely different environments. Its ultimate destination is the Selk impact crater, where organic compounds could have mixed with liquid water for extended periods, creating conditions that on Earth would be favorable for life. Understanding how Titan's atmosphere wobbles with the seasons will be crucial for calculating Dragonfly's landing trajectory, as the craft will descend through fast-moving winds while relying on optical navigation and mapping data from Cassini's previous flybys. Titan and the search for life. While Titan's surface temperatures are far too cold for life as we know it, the Moon offers multiple environments that astrobiologists find compelling. The surface chemistry, though exotic, involves the same basic building blocks found in Earth's primordial soup. The subsurface ocean, warmer and potentially more Earth-like in its chemistry, might offer conditions suitable for microbial life. Some scientists have even speculated about life forms that could exist in Titan's methane lakes, organisms with fundamentally different biochemistry that use liquid methane instead of water as their solvent. While this remains highly speculative, Titan forces us to expand our thinking about where and how life might emerge. A world worth exploring, Titan stands as one of the solar system's most compelling destinations for exploration. It's a world where familiar processes, weather, erosion, seasonal changes, operate through completely alien chemistry. It's a place where the building blocks of life accumulate continuously, where liquid covers the surface in lakes and seas, and where a thick atmosphere creates complex weather systems. The Moon challenges our assumptions about chemistry, planetary science, and the conditions necessary for life. Every discovery about Titan seems to raise as many questions as it answers. How does it maintain its atmosphere over geological time? What processes shape its surface? Could its subsurface ocean harbor life? What can its organic chemistry teach us about life's origins on Earth? As Dragonfly prepares for its journey, Titan awaits, a frozen laboratory conducting experiments in chemistry and geology that have been running for billions of years. When the rotorcraft finally touches down on that distant shore in 2034, it will mark humanity's return to Saturn's most enigmatic moon for the first time since the Huygens probe landed there in 2005. As a conclusion, Titan reminds us that the universe is far stranger and more wonderful than we often imagine. Here is a moon that looks like Earth in many ways, with rivers, lakes, rain, and clouds, yet operates through such alien chemistry that water is rock and rocks can evaporate. It's a world where fundamental rules of chemistry might behave differently than we expect, where atmospheres can wobble independently of the surface below, and where the ingredients for life accumulate in vast quantities. As we peer through the orange haze of this distant world, we're not just seeing another moon. We're looking at a laboratory for understanding how complex organic chemistry emerges in the cosmos, how planets and moons evolve, and potentially how the building blocks of life first came together on the early Earth. Titan is more than Saturn's largest satellite. It's a window into our own planet's ancient past and a glimpse of the incredible diversity of worlds that exist throughout our solar system. The answers to Titan's mysteries await discovery, and soon Dragonfly will fly through that thick orange sky, searching for clues about one of the most profound questions we can ask. How does life begin? If you enjoyed this journey through the terrifying beauty of space, make sure to like this video, subscribe to the channel, and turn on the notification bell so you don't miss what's coming next.